everybody. First of all, before we begin, I would like to say that we are a company, a Catalan company founded in 2011 of a little over 30 workers. So please take into account this, that we are not a university, we are not the level maybe of the research here is a little bit different, but the thing is that this is real application of science and engineering to day-to-day things that we find in our homes, in our shops. And so I think it's nice to be here and explain these things to all of you. We will talk about GasN2's chromatographic MAP generation plants, energetic savings, and microbiological safety, a comparison with traditional supply systems. So, consumers of food, all of us, or when we go to the shops, we are looking for healthy products, appealable products, products that have a long shelf life, and that of course they look nice, they smell nice, and that we can keep in the fridge for as long as possible. For these reasons, the food sector has had to develop strategies in order to obtain these goals. In this sense, the use of modified atmosphere packaging has been one of the revolutions of the field. MAP packaging has two main goals. The first one is to prevent the decay of the product, especially the microbiological growth, so that the food stays healthy. But the other is to maintain the organoleptic properties of the product. As I was saying before, we want the products to look nice and smell nice and have a nice color, and that is what MAP is looking for. Traditional supply systems are produced in huge generation plants that supply these gases to the clients in the form of compressed gas bottles or tanks. In the end, what clients pay for is gas, but also you have to take into account that this gas has to be taken from the production plants to the client, which means logistic transportation. This is a lot of energy waste. And also gas leaks, gas loss. And also other things, which are rental of equipment, delivery, discharge fees, etc. Our system, what is about, is to install a chromatographic system in the facilities of the clients that produces these MAP gases directly from air, so that the client really pays for the gas only, not transportation, not fees, not delivery charges, only gas. Another thing to take into account is that traditional systems basically use three gases, which is oxygen, nitrogen, and carbon dioxide. This work also will try to show that our system does not use carbon dioxide, which is, we think it's very important. And we will see a little bit further why. For example, things that we are not looking for when we go to a shop. This package here is shrinked. There is a depression on the plastic film. This is a very typical situation when we have CO2 in the package. The chemical equilibrium with CO2 and water that gives bicarbonate and protons makes that the result is that the gas that's on the gas phase goes to the liquid phase, so that the pressure inside the package diminishes, and there is this vacuum effect that makes this depression here. This is something the customers don't like. Another very important thing that I was talking about previously of organoleptic properties is with this same reaction we have protons in the media. which means that we acidify the product, which means as well that the organoleptic properties change. Something else, this equilibrium works the other way around. So once we have bicarbonate and protons, it can go back to water. This water, however, does not return inside the tissues, inside the product, but stays on the films in the form of water. Sure, we have all seen in the shops packages of meat with pads underneath that are wet. These special pads are designed to absorb this water, which is undesirable for the producers. Another thing that is not desirable is overpressure. Overpressure inside the packages has two sources. One of them is easy to solve. It's simply the packaging machine is malfunctioning. We have put inside too much gas. This is not a big deal. The other one is not that simple. It's microbiological growth. And this is a real problem, and we must prevent it. So what is our system? This is our chromatographic system. Of course, it's very different from the ones we've seen in the previous talks. We have an air compressor, a dryer to eliminate humidity, filters to ensure the purity of the air, accumulation tank, and this is the core of the system. This is our chromatographic system. These columns, so that you can imagine the magnitude, are 2 meters high, 25 centimeters wide. Our machines are modular, so the more you want to produce, the more columns you have. And you can go from 2 cubic meters per hour to 150, 200 maybe. Also, we have accumulation tanks for the product, and also other filters can be put to, again, make sure that the gas that goes inside the food packages is safe. What's the first question we tried to answer? Are we comparable to traditional supply systems? This is our competitors making us ask this kind of questions so that we can be competitive with them. The thing is that this question is really easy. When we go to our clients, no one would buy a system that would make them reduce the expiration date. It would be nonsense. They would be losing money. So the truth is that with all the clients that have installed our systems, the expiration date is maintained. In this graph, we have plotted fresh meat products, marinated products, and breaded products mainly. It's the same everywhere. The expiration date is maintained. Here, the experiment, the analysis that was made is regular microbiological analysis, Salmonella investigation, E. coli, Clostridium, the regular things that are analyzed when we want to assess food safety. Next, I talked about previously organoleptic properties. We asked subjects to test products and to evaluate their appearance, taste, odor, color, smell. Here are 3 examples. In this case, it's fresh hamburgers, beef, with 70%, in our case, the green series, 70%, 30% CO2. With the traditional system, nitrogen. With the traditional system, nitrogen is not used, but they use CO2, which is what I was talking about. In the second graph, pretty much the same for ham, and the third graph for fresh pork sausage. What we found in all of the cases is pretty much the same. This period here, up until the red dotted line, which is expiration date, The truth is that the products that were using our systems scored significantly higher, better results in terms of appearance than those using traditional supply systems. We also have to say, however, that after the expiration date, the rate of decay of our products is worse. This is the truth. But what is important to see here is that this period here until the expiration date is when the products are on the shelf of the store. This is where the consumers buy. So this is what is important for our customers. Ham's the same, sausage is the same, with other products is the same. I must say that right now, I showed previously in the previous slide, I think it was 30 products. Right now, we can say that as for October 2017, we have more than 200 references going from meat, but also fish, ready-to-go meals, snacks, dried fruit, and several more kinds of products. And the results are pretty much the same all the time. Also, we tried to calculate what was the economic impact of these systems compared to traditional supply systems. We analyzed 30 of our companies. I did not put the name because of confidentiality issues. We analyzed the amount of money they were spending using for their MAP systems. Most of the companies spend around from 5% to 10% of their turnover in MAP systems. Once the system is swapped to GasN2 chromatographic plant, this amount goes down to 2.5 to 5%. This means a decrease to up to 37.9% reduction of the cost of MAP systems for the company, which is a lot. So, to finish, I would like to say that this technology that I have spoken about, we use it for food sector, but we are also applying it to other sectors such as fire prevention, pharmaceutical sector, plastic injection, laser cutting, and a few more, which is very interesting. As I was saying before, we are a small company, but we are really devoted to keep researching, to collaborating with universities, and to keep improving our products. So if any of you that work with chromatography and want to collaborate with us and we can find strategies together, just feel free to contact us with any of the channels we have. Thank you for your attention.